Hello and welcome to Add-on. So, the question is find the Fourier sine transform of a function fx is equal to e raised to the power minus ax divided by x. That is, we need to find Fourier sine transform of a function fx जो होता है integration 0 to infinity f of x sine sx dx. This is the formula for Fourier sine transform that you need to remember to solve this. So, using this formula, ये हो जाएगा integration 0 to infinity. Put the value of fx which is e raised to the power minus ax divided by x sine sx dx. And it is the value for f of xs. Since Fourier transform of a function fx is equal to fs. So, it is fs. And for sine transform, we use s here. So, it is integration 0 to infinity e raised to the power minus ax divided by x sine sx dx. Now, to solve this further, differentiate both sides with respect to s. So that ये हो जाएगा d upon ds Fourier transform का derivative. So, एक बार हम derivative लेंगे. Now we take integration. Integration and derivative will give us Fourier transform of a function s. So, हम इसको as it is रहने देंगे while taking derivative and we will do right hand side. So, left hand side will be as it is, that is d upon ds derivative of f of s is equal to d upon ds integration 0 to infinity e raised to the power minus ax divided by x sine sx dx. Now, left hand side will remain as it is. We will solve for right hand side. So, to solve this integral, ये हो जाएगा integration 0 to infinity derivative of e raised to the power minus ax upon x sine sx dx. Now, derivative is with respect to s. So, हमें सिर्फ इस टर्म की ज़रूरत है. Then it is integration 0 to infinity e raised to the power minus ax divided by x. Take derivative of sine sx dx. Now, derivative of sine is cos. So, it is integration 0 to infinity e raised to the power minus ax divided by x. And derivative is x cos sx with dx. जिसमें x से x cancel हो जाएगा. Then it is integration 0 to infinity e raised to the power minus ax cos sx dx. Now, we know the formula for this integral जो होता है integration e raised to the power ax cos bx dx is equal to e raised to the power ax divided by a square plus b square in bracket a cos bx plus b sin bx. So, using this, हमारे पास आ जाएगा e raised to the power minus ax since a के प्लेस पे यहाँ minus a है divided by minus a का whole square plus b square. Now a के प्लेस पे it is minus a, cos b के प्लेस पे it is sx plus s sin sx. And limit is from 0 to infinity. Now put limit, it is 1 upon a square plus b square. Take it common. Now e raised to the power minus infinity, this whole term minus a cos s infinity plus s sin infinity minus e raised to the power 0 minus a cos 0 plus s sin 0, जिसमें e raised to the power minus infinity is 1 upon e raised to the power infinity, which is 1 upon infinity, that is 0. So, ये वाली पूरी term will be equal to 0. Now, e raised to the power 0 is equal to 1 and cos 0 is equal to 1 and sin 0 is 0. So, using all this, हमारे पास आ जाएगा it is 1 upon a square plus b square in bracket 0 minus 1 minus a plus 0, जो हो जाएगा 1 upon a square plus b square minus minus plus, then it is a. This is equal to a upon a square plus b square. And question में b was s, जो हमने put ही नहीं किया, so it is a upon a square plus s square. So this is the answer for derivative of Fourier sine transform of a function s. fx. So now हमें सिर्फ Fourier साइन ट्रांसफॉर्म चाहिए, हमें उसका डेरिवेटिव नहीं चाहिए. So we take the integration on both sides. Now take integration on both sides. So it is integration d upon ds fs s is equal to integration a upon a square plus s square ds. Now integration with respect to s. So ये हो जाएगा Fourier sine transform of a function fx, that is fss is equal to, now integration of a square plus s square, इसको separate कर लेते हैं, a integration 1 upon a square plus s square ds. Now using formula, using integration of 1 upon x square plus a square dx is equal to 1 upon a tan inverse x upon a. So here it is a integration 1 upon a square plus s square, where s is in place of x. So it is 1 upon a multiply 1 upon a के place पे a है, tan inverse x के place पे it is s divided by a, जिसमें a से a cancel हो जाएगा. It is tan inverse s upon a plus c. C is an integration constant. Now we need to know this unknown value. जिसके लिए we take s is equal to 0, जो हम put करेंगे in this equation. Mark this as 1. Putting in this, f as 0 gives in equation 1, which was f as s is equal to integration 0 to infinity e raised to the power minus ax divided by x sine sx dx. Now putting 0 in place of s, it is, this implies f as 0 is equal to integration 0 to infinity e raised to the power minus ax divided by x sine 0 dx, and sine 0 is 0. तो ये क्या हो जाएगा, f as 0 is equal to 0. Now using this we take 0 here. हमारे पास फाइनल इक्वेशन आई थी एफ एस एस इज इक्वल टू tan inverse s upon a plus c. To eliminate c, we take s is equal to 0 on both sides, which gives f as 0 is equal to tan inverse 0 divided by a plus c. Now it is tan inverse 0 plus c. This thing is already 0, जो हमने यहाँ find out की थी. Then this implies 0 is equal to tan inverse 0 is 0 plus c. This implies c is equal to 0. Now c की वैल्यू 0 पुट करेंगे. So हमारे पास फाइनल आंसर क्या आएगा? From this it is f s s is equal to tan inverse s upon a plus 0. c के प्लेस पे 0. Then it is finally tan inverse s upon a. That is Fourier sine transform of a function e raised to the power minus ax divided by x is equal to tan inverse s divided by a. Hence it is done.